Hi, I'm Jasmine. So in this video, we'll go over how we can use Python to automate the recording and processing of our enDAQ sensors so we can be almost completely hands-off.
Alright, let's go over how we can get our enDAQ devices to start recording straight from a program so we can be almost completely hands-off. Now before we get to coding, we have to make sure that the device is configured appropriately to work with the computer. So for this demo, I'll use the W5 in the corner here, which is plugged in and will stay plugged in for this demo. So first we want to set our plugin action to be anything but that top option of immediately stopping, as this will mean we wouldn't be able to get any recording when the device is plugged in. So now if we head to the triggers tab, we'll want to set either a time limit or a file size limit so the device can finish and reconnect on its own, since I plan not to touch the device for the whole process. Apply your changes, and I've already got mine configured. We'll head to the code. So we'll want our enDAQ.device library installed and ready, and we can scan all of our drives for our devices using enDAQ.devices get devices, which will show me a list of the 2 devices that I currently have plugged. So the second is my W5 here, so I'm going to index it as such, and I can set it off with .start recording. And this will follow the exact configuration that is saved to the device. Then I'm going to call get devices again. And if I run, the device has the green LED blinking here, which means that it is in fact recording. And if I try to check the devices immediately after, we'll notice the W5 is missing, even though it's plugged in. This is deliberate, so in order to work with the device, we have to wait for it to finish, and it should reconnect on its own. So now it's finished, I can check the devices again, and it should be readily available. And another thing we can grab from our device is the path and get the drive that it's sitting in. So now I'm going to walk through a sample program with creating a recording and processing the file multiple times. So I'm going to use the OS library to make a directory path to where all my files are, using that drive location and the data record file. I'll make a recordings variable for the number of runtimes for the loop that I'm going to make, and I'll have the device declared. So onto the loop. I'm going to set this to have 3 recordings, and for each iteration I want to tell my device to start recording, and it's important here that we followed that very first step with configuring the device to be able to come back as a drive, or otherwise this loop would break. So I'll make a print statement to make sure that we know it started recording. And I'll use the time library to have my program sleep for 7 seconds while I wait for the device to finish recording and to reconnect to the computer. And a better way to do this would be to have the program scan for the device at smaller time intervals, since the device might not need much of this cushion time to reappear. And then by this point, the device and its new recording should be available. So we can use our OS library once again and start grabbing the file and the location of this. Okay, so I'll use os.lister to just grab the file name, and we'll use the last one out of this list for the newest. Then I can combine this file name with the path directory using os.path.join, and I'm going to use that full file path now with our enDAQ IDEs getDoc to grab our dataset. So here's where you would process your file. I'm just going to print and move on to the next iteration with our recording variable we set at the top. So now let's run, and we'll see that the recording has started, and it should come back just a few seconds later. I'm going to skip ahead to the end of this loop, and we'll find all of our recordings as expected. So it looks like the finish. And there's our data sets. So there is our file full of our new data sets, and that'll be all for this video.
Thanks for watching. I hope you found this useful. For similar videos, go visit and subscribe to our YouTube channel, enDAQ Technology, and happy coding!